Okay, so you might remember from the beginning of the year that we talked about these terms and vocabulary words like quotient, and we've used them throughout the year a couple times, but not not always regularly. So this next exponential property or exponent property is going to be talking about the quotient rule. Well, you might remember that quotient just means divide, right? So what do we do when we're dividing exponents? All right, well, let's look at some examples. So 2 to the third power and 2 to the second power. Well, 2 to the third power is like 2 times 2 times 2. And 2 to the second power is like 2 times 2. Well, we know that these terms on top and bottom, right, can be divided by each other. So we can essentially say that this 2 and this 2 cancel out, and this 2 and this 2 cancel out. And so we're just left with a single 2 on the top. So these you can see right here, cancel, cancel, and I'm left with 2 to the first power. Let's look at a couple more examples and see if you can figure out what's happening here, or an easier way, just like we did in the previous ones, an easier way to solve it. So I've got 3 to the 7th. Let me go ahead and write my 7 threes here. And then I've got 3 to the 4th, so I've got 4 threes on the bottom. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, so again, on top and bottom, each time I have a pair of threes, I can kind of cancel them out. Okay, and then boom, boom. Well, how many am I left with? I'm left with a total of 3 threes, right? So you can see I did my canceling over here, so I didn't have to write it 2 times. But you can see I'm left with 3 threes. Well, 3 threes is the same thing as saying 3 to the third power. So let's see if we can figure out, let's do one more, and let's see if we can figure out how do we get from 3 and 2 to 1, and 7 and 4 to 3. Okay, I'm going to do x to the 10th, so I'm going to put 10 x's on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 4 x's on the bottom because x to the 4th. And then I'm going to cancel them out. 1, 2, 1, 2, 1, 2, 1, 2. How many am I left with? 1, 2, 3, 4, 5, 6. Right? I'm left with x to the 6th power. But how am I getting there? What's a different way to figure it out? Well, 3 and 2. How do I get a 1 from a 3 and a 2? Well, most of you would very quickly go, oh, well, you subtracted the top number of exponents and subtracted the bottom number of exponents, and you got the total number left, which is 1. So let's try this one. Does it work? Let's see if our rule applies to the next one. 7 minus 4. Does 7 minus 4 equal 3? Yes, it does, right? So just like when we were multiplying exponents, we added the exponents. If we're dividing exponents, we're going to subtract our exponents. So when we get to this bigger example, look at the numbers that go together. We have 5 to the 12th and 5 to the 7th. It's too big to write this out, but let's think about the exponent rule we're just learning. 12 and 7, we would subtract those. Well, what is 12 minus 7? Again, if you can't figure things like that out in your head, just use your calculator, right? So don't stress. 12 minus 7 should give you 5. Okay, so my 5 term, when I take the 12 fives and I subtract 7 fives, or I cancel out 7 fives from them, I end up with just 5 fives left, or 5 to the 5th power. And y to the 20th and y to the 8th, if I do 20 minus 8, I'm going to end up with 12 left. Okay, I canceled 8 from the top, and I end up with y to the 12th. All right, let's work backwards and see if we can figure out what might this have come from, right? What number could we get where we would end up with a 7? Well, we could do something as easy as 8 minus 1, right? So if I had 8 A's on top, 1, 2, 3, 4, 5, 6, 7, and 1 on the bottom, right? That would have canceled and left me with a to the 7th. So a to the 8th over a, or a to the 1st, right, would work to give me the a to the 7th. Well, how could I get a 3? Well, I could do a 10 minus a 7. I could do a 6 minus a 3, right? Anything would really, there's multiple options that would work here. Let's do 6 minus 3, just because it requires me to write fewer b's. 3 together. So 6 b's on top and 3 b's on bottom, right? So I've got b to the 6th and b to the 3rd, which means that these 3 would cancel with these 3. right? And this one cancels with that one, and that would be a way that I could get a to the 7th and b to the 3rd. All right, so what is the rule for what happens when you divide terms with exponents and the same bases? The rule is subtract the top exponent minus the bottom. So let's give an example. A to the m divided by a to the n is equal to a to the m minus n. Whatever these exponents might be, I would take the top one and subtract the bottom one, and I would end up with the number of exponents I should have.